Alright, in this lesson we're looking at integrating by using simple partial fractions. If you haven't already, make sure you read through the first page of these notes where we've got an illustrated example walking through the process. So what we want to do in this first example is we want to break this down into two partial fractions, since we have a denominator that breaks down into two factors. Factors of the denominator are x minus 5 and x minus 2. And so we're going to rewrite this integrand as a over x minus 5 plus b over x minus 2. Alright, so that means that we need a times x minus 2 plus b times x minus 5 to be equal to the original numerator of our fraction. And so we can write a system of equations based off of this. A plus b has to be equal to 2. And negative 2a minus 5b has to be equal to negative 5. Alright, because a times x and b times x, when we add them together, have to equal all the x's in that expression, and negative 2 times a and negative 5 times b have to be equal to negative 5. Alright, now once we've written our system of equations, we need to solve it. I'm going to take 2 times the first equation and add it to the second. That eliminates the a's, gives us negative 3b is equal to negative 1. So b is equal to 1/3. And substituting that back into the first equation, we get that a is equal to 5/3. And so now we can rewrite this integral as the integral of 5/3 times 1 over x minus 5 plus, actually let me put that 5/3 out in front of the integral. Plus 1/3 times the integral of 1 over x minus 2. And when we're using partial fractions, a lot of the times the integration is probably the easiest part. Figuring out your system of equations and solving your system of equations is a lot more involved than actually finding the integral, because the integral of this one that's just going to be a natural log. And that's just going to be a natural log. And my constant of integration. And there's my integral. Alright, let's do the next example here. We're going to integrate the integral of 3x plus 5 over 2x squared minus 5x minus 3 dx. So the first thing I'm going to do is find the factorization of my denominator. Let's see, it's going to be 2x plus 1 times x minus 3, and so those are the two factors that are going to go into my denominators and my new fractions. Alright, and so a times x minus 3 plus b times 2x plus 1 has to be equal to my original denominator. Now writing my system, that gives me a plus 2b has to equal 3, and negative 3a plus 1b has to be equal to 5. I'm going to solve this system. I'm going to multiply the first equation by 3 and add the two together. That gives me 7b equals 14. So b has to equal 2, and a has to equal negative 1. Yeah, negative 1. Alright, so this turns into the integral, negative the integral of 1 over 2x plus 1 plus 2 times the integral of 1 over x minus 3. Now I'm going to integrate both of those. The first one, be careful that you use the chain rule in reverse or you use substitution to find this integral, because we're going to end up with a 1/2 out in front, because when we take the derivative of the natural logarithm of the absolute value of 2x plus 1, the chain rule requires us to multiply by 2. That's one where I see students frequently get caught whenever they have a denominator here with a natural log where the x coefficient is something other than 1. It's a common student mistake I've seen over the years. But outside of that, pretty straightforward. Probably the most difficult thing was finding our factorization in the beginning. And then there's our solution to example 2. Alright. Example 3 is a little hairy, a little tougher to factor here. I'm going to factor this by grouping. We've got x to the third and a plus 3x squared minus 4x minus 12. I like to factor by grouping this way. I can take an x squared out of the top row. That's x, that's plus 3 minus 4. So this factors as x plus 3 times x squared minus 4. And x squared minus 4 further factors as x plus 2 times x minus 2. So here we're actually going to have 3 fractions in our partial fraction decomposition. One with a denominator representing each factor. And so when we go to write out our expression that we're going to use to find our system, the a needs to be multiplied by both of the other denominators, x plus 2 and x minus 2, to get it back to the original denominator. So we're going to multiply that by x squared minus 4. The b needs to be multiplied by x plus 3 and x minus 2, which is x squared plus x minus 6. And the c needs to be multiplied by x plus 3 times x plus 2, which is x squared plus 5x plus 6. And that all needs to be equal to x squared plus 3x minus 6. So my system is going to be a plus b plus c is equal to 1. And that's because of the x squareds. And then my second equation in my system is going to be b plus 5c is equal to 3. And that's because of the x's. And then my last equation in my system is going to be negative 4a minus 6b plus 6c is equal to negative 6. Now I need to solve this system. My recommendation would be, since I already have one equation that's missing an a, to combine the other two and get rid of a. So I'm going to multiply the whole first equation by 4 and add that to the second equation. So let's see, that's going to give me, cancel my a's, it's going to give me negative 2b plus 10c is negative 2. And then I'm going to use these two equations and get rid of one of the variables. Let's see, I'll multiply the first equation by 2 and add them together. And so I get, let's see, my b's cancel, I get 20c equals 4. So c is 1/5. which then substituting back into this equation gives me b is equal to 2, and then a has to be equal to negative 6/5. So my integral becomes negative 6/5 integral of 1 over x plus 3 plus 2 integral of 1 over x plus 2 plus 1/5 integral of 1 over x minus 2, and so this ends up becoming negative 6/5 natural log of the absolute value of x plus 3 plus 2 natural log of the absolute value of x plus 2 plus 1/5 natural log of the absolute value of x minus 2 plus c. And that is the integral of x squared plus 3x minus 6 all over x to the third plus 3x squared minus 4x minus 12. And that is simple integration by parts, where all we have is linear factors in the denominator when we factor it. All right, see you next time.